Ouch! Hey, welcome back. You guessed it by the intro already, and maybe by the title of the video. Today I wanted to talk about burrs and deburring, proper deburring techniques, good practices, and the tools we use for deburring. So let's get started right away. Let's do some theory. Okay, let's begin with the most important question. What is a burr? A burr is annoying as heck. And a burr is a geometric formation that is created whenever you do a chip removal process. Every chip removal process will basically end up with a burr. Let's say we have this part here, and we take a facing cut with this rather large shell end mill along its top surface, just like this. Everything's nice, the end mill takes a chip, but on the point where the cutting edge leaves the material, it will not cleanly cut off every last bit of the material, but it will bend over the last bit of material. Just like I showed here. Draw this in cross section, and the cutting edge of the end mill exits the part, and you get a burr on this side. So you get an overhang, and this overhang can be razor sharp. So in most cases when we do machining, fabricating or whatever in the shop, a burr is absolutely not acceptable. You want to remove it. And that's what this video is about. Deburring, chamfering or rounding over. So there are different styles of deburring, or different ways to do things. You can either deburr. Plain deburring does not do anything to the... It creates just a sharp edge without a burr. A dead sharp corner. Perfect intersection of two flat surfaces. A chamfer is, most cases, 45 degree. You nip off the edge and you create a chamfer. And sometimes you want a round over, where you put a nice radius on the edge of a part. There are different uses for each style, and rounding over, for example, is often used when you have parts that get handled, that people have to touch and handle and operate. Chamfering is often used when you do machine deburring, when you run a 90-degree chamfer end mill in a CNC machine, because it's just plain old stupid fast. Or you like the faceted look of a nice crisp chamfer. This, on the other hand, is often important as a function. You cannot deburr or you cannot chamfer the end of let's say a punch that has to cut the material by shearing. You want a crisp edge without a burr, but also no corner break or no round over. And also a burr doesn't help either, because it would, in case of a punch, you would destroy the lower die. And then there is this term secondary burr. You see often people just take a file to a workpiece, file off the edges, and call it done. Call it deburred or chamfered. Problem is, the file is of course also a chip removal tool, and hence so it will create a burr on its own. When you file a chamfer onto a workpiece, you will create a secondary burr. Same happens when you use a countersink to remove a burr from a drilled hole. It will also create a very, very small burr that you should remove if you want to do a proper job. You can leave it there if you want to do a sloppy job, but in a proper case you would remove a secondary burr any time. Otherwise it's just a hack job. There is literally a metric ton of deburring tools out there, from hand tools to attachments for power tools to power tools, air tools, and even machine tools that do deburring, chamfering, and rounding over. And I hope that I can go into most of them in this video without making it too boring and too long. So let's start with something basic that everyone in a shop should know how to handle: a basic file. Okay, these are your basic styles of files. You have full-size files. This is also full-size. And you have an intermittent size. In Germany we call them Schlüsselfile, or might be translated to keyhole file. And needle files. Full-size files generally come with a wooden handle or a plastic handle, which sucks. And you get them in different sizes, all shapes that you need, and different cuts. You can get them single cut and cross cut, and also different number of cut. The higher the number, the finer the file, at least with the German system of numbering. I don't want to make a filing tutorial out of this, but might be a good idea to show it anyway. This is a single cut and this is a cross cut file. Single cut means that the teeth, there is only a set of teeth in one direction, like this on this file. They are all in this direction and parallel to each other. On a cross cut file, you have a set of teeth going this direction and a set of teeth in this direction. So it creates this cross hatch pattern. Generally, the single cut file is for materials that tend to load up a file, like aluminum, lead, or soft materials in general. And the cross cut file is for harder materials, steel, brass, stuff like that. But to be perfectly honest, 99% of my files in the shop are cross-cut. I think this is the only single-cut file that I have. And this is even not a normal bench file, this is a lathe file, because it has it is cut at an angle of 45 degrees for better chip evacuation when you use it on the lathe. And here is the roughness of the cut compared. This is a number 1 cut, cross-cut file, and this is a number 3, which is literally very fine. Again, I think I have 2 files in number 1 cut and about 1 million in number 3. So most of my files are really for fine work. This one rough file gets not very much use. And then you have, of course, your needle files, which I use the most. These are all fine cut, I think number 3 or number 4 needle files. Some are Swiss, some are German. And I also have Riffler files. But let's go step for step. These are your classic needle files. They don't come with a handle. There are handles you can clamp on, or you just use them like this. I prefer them without a handle. You have flat, this is triangular, square, all your basic shapes. And then you have your Riffler needle files. These are sometimes referred as sculpting files, but also the tool and die guys and the mold makers use them quite a lot. And I think the gun stock makers use them for to work on gun stocks, to put in the fish scaling. They're relatively expensive, but if you have to use them, there is no way around them. You have to have a few sizes. I like a triangular Riffler file with the edge pointing down, so you can deburr into a slot. And a knife shape comes in handy often. And if you can get a rounded Riffler file, that's also very handy. You can get the needle files also with a diamond coating, which can be useful if you work with carbide or glass or ceramic or fiberglass, reinforced plastics. So let's look into the let's do finally some deburring. We have a piece of 5mm cold rolled sheet metal here, and I face milled the top, and I have a burr over here. Not a very big, but when I run my fingernail across it, I think you can hear it. So when we deburr something, we want to think about what we're doing. Do we want deburr, chamfer, or roundover? Let's say this is part of a large punch and die set, and it needs to have sharp corners because it's a cutting element. You cannot just take a file and go like this and put a heavy chamfer on it and throw it in the trash bin. You want to you want to deburr it properly. When we just take off the burr, you can take a file, for example, flat on top, and you run it across the flat surface and to the same on this side. And you just run the file across the flat surface. And you will initially feel the file grabbing the burr that hangs over the edge. And once you remove the burr, you will feel that, for example, a lead pencil will not catch on the edge anymore. That means it's deburred. It's a razor sharp edge now, but it has no burr. And in a lot of cases that's something that you want. Maybe you are in the process of machining a part and you do not know yet if you need the corner sharp or deburred in the end. So it's better to keep all the edges deburred and sharp until the end and do eventual roundover or chamfering at the end. You can also, if a part is flat, take your flat file like this and just go across the surface like this. And remove all burrs and nicks from handling and machining it. This part doesn't have many burrs. But what's more common, you want to chamfer the edge. Most people just take a file and file like this and create a chamfer. .45°, file it, and the problem is you create a burr that way. Now we have a burr down here on the edge where the chamfer meets the flat surface. And then again you would have to run your file across the surface like this. Or if you want to put a chamfer on the edge, you take a file that is large enough and run it across the length of the part. This file is too short. Let's take a proper one. That way you can create a very nice, neat chamfer without creating secondary burr. Doing a chamfer like this takes some practice. You will, if you're not practiced doing it, you will end up with a chamfer that is heavier on one end than the other. It takes really some time to get used to it, but that's a very, very good way to do a chamfer. Also, the chamfer will get a better surface finish that way, because you're cutting with a multiple number of teeth in engagement all the time. The worst thing you can do is going 90 degrees to the part and filing like this. Yeah, I can't even do that. This will create a horrendous burr on the end of the chamfer. If you have no other choice, at least angle the file 45 degree and file like this. And when we get a secondary burr, we can just angle the file a little bit up and run it, take a very light pass just to nick off the burr created by the file. Some people hate it, some people do it like this. They just, if you want to have a quick deburr, they just hold the part in the hand, file in the other, propping the back with the finger, holding it steady against something solid. And chamfering the edge of a part like this. Speaking of chamfering, if you want to do a round over, you begin by filing a 45 degree chamfer like this. And then they do two chamfers next to it, half the angle, 22.5, something like that, like this. And like this. And then they just blend it over. And that way you can get a relatively good round over. I'm showing this freehand right now because yeah, most of the people do it freehand. What I really like to use for deburring is a parallel that has 180 grit emery cloth stuck to it with some double-sided tape. I just take a parallel and stick the 240 grit or 180 grit on there, and then I run it across the surface with the burrs sticking up. And this knocks down all the burrs on the edges. This is nothing for precision parts that are not allowed to have any sanding marks in it, because as you can see it alters also the surface finish. But it's excellent during machining operations to knock down burrs. For example, when you drilled and your countersink created a very light burr, just take your sanding, it's a sanding block basically, and run it across the surface and it knocks down the burr. This piece here is an example. This has a burr here on the edge of this hole. Now just take the sanding block and I knock it down, and the burr is gone, and also the burr on the edge of the part. This is something I have. I have a few of these at work, and I have a few here in the shop. And I really use them all the time. It's one of the more useful things for deburring. If you're deburring hardened parts or parts with that need a very good surface finish and finish on the chamfer or on the deburr, stones are what you're going to use most cases. Regular India or silicon carbide stones, India or aluminum oxide, are used for steel, hardened steel, soft steel, stuff like that. And silicon carbide stones are used for cast iron and carbide. Then you have your ruby stones, which are basically synthetic ruby. There is a famous German company, Frialit, that makes these under the trade name Degusit. And these are horribly expensive, but they are, these are like burnishing stones. These are for finishing, deburring, surface finishing, stuff like that. Really nice. And you have your bench stones. This happens to be a set of precision ground flat stones, like Robin Renzetti showed in his video. I will put a link to his excellent video on these stones down in the description. So a normal stone, like this triangular India stone, can be used just like a file for deburring. All the same techniques like with a file apply with it. You can run them across flat surfaces to remove the burr that stands over the edge. You can use them 45 degree to create a chamfer, or you can use them like this to create a slight roundover, or like this. And you can use them over the whole surface of a flat part to knock down burrs and nicks and things. But the stone cut's relatively aggressive, so you will put a scratch pattern into the surface. The Degusit or ruby stones, on the other hand, these don't cut into surfaces. You can rub here across the surface until end of days, and you will really only knock down the high spots just like the precision ground flat stones. But they come in handy for deburring and chamfering and rounding over to a very high degree of precision. And the nice thing about these is they work in steel, carbide, glass, aluminum, plastic, whatever you want. They deburr, burnish and finish and do everything. And they are hard as frick. They will not wear down. If you do not drop them, they will last you forever. And if you drop them, you will end up with two, basically. But they will not change their shape. They basically do not wear down. But they are expensive. A bench stone this size in this material costs about $100. One. And then you have your precision ground flat stones, which I will not go into detail, but just show. These are great to remove burrs from very precise parts, just to knock the burr down and burnish the surface. Then you have your classic deburring tool. For example, made by Noga. Everybody has these, and I'm not a big fan of them because it's very hard to get a consistent edge break or deburr with them. They tend to catch and gouge the work. They are good for quick fabrication work, but for precision machining operations and precision deburring, I don't think that this is the right tool. You can get them with different blades. This is a very basic style of deburring blade, general purpose, very heavy duty, but it has this large head on the end, and you cannot get into narrow slots or stuff like that. I prefer this style here, with the narrow blade, because you can get into relatively small slots and deburr small holes and feature some parts. Also, you have to be careful when you order these blades. You can get them in tool steel, high-speed steel, and even carbide. And for more exotic materials, even diamond coated and titanium nitride coated, I think. But also there are shapes that are right-handed, left-handed, and neutral. If you use a blade that is not neutral in the wrong direction, it will not work properly. So you have to look at that. You have to look at that too. One very useful style of blades, but that seems to get harder and harder to order, is this one with the nick in it. It has cut a small nick in it, and this is used with the nick across the edge. And this will guide the blade very nicely along the edge, especially when your part looks like this and you want to deburr this edge here. When you use a normal deburring tool like this, you will end up scratching this lower surface with the tip of the blade. The nicked deburring blade will run across the edge, and you cannot physically move down into the other surface. So these are very useful. The use of these tools is really very basic. Get it on the edge, put on some pressure and drag it along. Just like this. And it will pull off a nice chip from the part. They work really well on straight surfaces and internal curves. But outside radii, these are horrible. It's really hard to control them around the surface. For example, this piece of cast iron pipe. The inside is really nice to deburr with this. Just walk along. But the outside is really hard to deburr with it. It's really hard to get a good cut, and you will end up stabbing this in your hand. So I think there are better tools for this. Even a file will do a better job on this. Speaking of file on rounded parts, if you want to deburr something round with a file for whatever reason, maybe you cannot chuck it up in a lathe, it helps to put it in half-opened vise or in a V-block and go around like this, and you can chamfer even round parts relatively good, but not with the deburring tool. This, yeah, no fun. One last tool that I use very lot for manual deburring by hand is a scalpel or surgical blade, or even a box cutter knife or single edge razor blade. Especially as I do very much plastic at work, this is my preferred deburring tool there. I don't care for the X-Acto blades. I go for the surgical blades from a proper, good manufacturer. I think these are, there's a German company making these. And the difference between a good and a bad surgical blade is the cheap ones from eBay China will snap. They are very brittle, and the good ones like this is very flexible, and you can bend them quite a bit before they break. You can use them for cutting, scraping, and scratching burrs. Mainly in plastic. You just take your piece of plastic that has a sharp edge and that you want to have a slight chamfer on it. You take the blade in a steep angle, almost 90 degrees to the part, and you just scrape along the edge. This will not only create a terrible noise, but it will create a very clean chamfer on the edge. And you can also use a single edge razor blade like this. And this will throw up a slight secondary burr down here, but that is very easy to be removed also with the blade. And this will create a very clean chamfer on plastic. One last very exotic way of deburring is on hardened parts that do not allow an edge break at all. An old timer in work showed me this. When you grind hardened tool steel or high-speed steel or whatever that's hardened, you will end up with a very small burr pretty much any time you grind it. And when you want to remove it without interfering with the surfaces close to it, take a piece of brass and run it over the edge. Just like this. Brass or bronze will work quite well. Copper sometimes works too. And the soft material will conform to the sharp edge of the tool steel, and while you push it along, it will shear off all overhanging burr and create a very, very crisp and sharp edge without any burr on it at all. Old tool and die maker trick. Comes in handy about once every 5 years, but good to know. One tool that I started to use more and more and more for deburring is a die grinder with an assortment of tools. When I started out machining, I poo-pooed the die grinder for deburring because I was not very confident in using it, and I mangled up a few parts with a die grinder and a burr. But I try to use it more and more, and it's a very valuable, very fast way to deburr tools. And if you have a steady hand and the right tools, you can get an absolute perfect job with your tools to deburr a part. And as I said, it's fast and not very demanding physically. My die grinder happens to be an electric Proxon made in Germany die grinder that is basically the first power tool that I ever bought. I think I had this for over 15 years now, and it's still working. It's relatively loud, and if you buy a die grinder, make sure it comes with speed adjustment. This has this is 12 volt, and it has a adjustable power supply with PWM control. I have also a small pencil air die grinder, but I've taken it apart and it's in a box because I want to rebore and regrind the spindle taper. It has horrible runout. It's a cheap Chinese air die grinder. Air die grinders, of course, are beautiful. They run very high RPM, 60,000 RPM and more, and that's very nice if you want to use carbide burrs. This one goes up to 20,000 RPM, and that's on the edge of usefulness. A bit more would be nice, but I also want not to buy a Dremel, because I have a very strong opinion about Dremel power tools. So let's go into tools. By the way, do not bother with the carbide burrs or the flapper wheels that come with that you can buy from Dremel or Proxon. They are overpriced, and most of the time you can get them in industrial supply cheaper and in better quality. Okay, this is all 3mm or 1/8 inch shank tooling, and your die grinder should come with collets for that. These three tools here, these are carbide burrs. They are multi-flute milling cutters for freehand use. As they have a large number of flutes, you can use them freehand in a die grinder, and they will not catch like if you would chuck up a 2-flute carbide end mill in a die grinder. This would be horrendous. So You want multi-flute tools, you want them to be carbide and you want them to be reasonable quality. While I buy cheap Chinese diamond tools for my die grinder, I buy German Pferd carbide burrs because these are superior to anything that I used before. You get different shapes, of course, this teardrop shaped ball and a very pointy cone shape. These two are those that I use the most. These are, I found, the most useful ones. The ball shape is a bit dangerous. You will get into the idea that you can use it with the die grinders to deburr holes, and that will end in a relatively entertaining crash because it will catch and go all over the place. Don't try to use them in holes, but they are useful to deburr cross holes in a large bore because you can get in and move around. Then you have your grinding stones, either diamond or aluminum oxide or silicon carbide. I use most of the time in the El Cheapo diamond from eBay China. I found these to work quite well. They are dirt cheap and the run out on them is relatively good. And if 1 of 20 is a failure, I just throw it away because they are really spectacular cheap. These work for hard materials, carbide, tool grinding, stuff like that very well. Also, you can use them on steel because if you lower the speed, normally you shouldn't use diamond on soft steel because due to the heat of the grinding and the carbon affinity of the steel, something, the diamond will melt away and yada yada. And you end up with pretty bad lifetime of your tool, but as these are super cheap, meh. Cutoff wheels, small cutoff wheels. These work quite well for deburring, I found. You can run them across the edge or along the edge of a slot to create a small chamfer. Works very well. You just have to be careful. Don't put an awful amount of side load on them, otherwise they will shatter. Rubber bound grinding wheels. This is a grinding wheel with aluminum oxide grit in it, and it's flexible. These work very well to put a final touch on a deburring job, just to nick off any remaining fine fuzziness, secondary burr, stuff like that. And they wear down quite fast when you run them up against the hard edge. Flapper wheels. This is a more robust tool. This is good to remove heavy burrs. Not something I use very much. Steel wire wheel. These are great for deburring complicated shapes, but you have to be a bit careful. You will wash over contours, and if you have fine features machined on a part, you might lose them when you use a steel wire brush on it. Okay, let's do some deburring. I'm using the teardrop carbide burr at 20,000 RPM. And depending on what you do, you might want to go climb milling or conventional milling. If you go for conventional milling, you run into the danger of digging into the work, and when you go for climb milling, you run into the danger of getting or losing the control over the tool and going like crazy. So let's deburr the internal edge of this part, or chamfer it. It's hard to do a real deburr with the die grinder. This is more for chamfering. Sometimes with something like the end of a keyway, you want to use a very pointy tool like this cone shape, this narrow cone shape, and you just want the tool to walk itself along in clamp milling. You have to be super careful on the end of a feature so the burr does not roll over the edge and catch like just happened, which I did on purpose to show it to you, of course. Also the angle of attack you hold the burr makes a difference, because these are of course spiral fluted, and when you attack an edge like this and the tool rotates, it wants to dig in the edge, and when you skew it this way, the flutes are square to the edge and you get a better cut that way. Something like this, where a hole exits on a curved surface, is a good example where you might want to use a die grinder. When you use a normal counterboard deburr, something like this doesn't work very well because it's a rounded surface. But with the die grinder you can march your way around the edge of the hole and try to maintain a somewhat even chamfer. As you can see, this is a lighter chamfer I did here with the burr, and up here I tried to do a very heavy chamfer, and you saw me carving away quite some material with this tear-shaped burr. And also, these are relatively safe to operate. In most cases they will not cut into flesh and bone. Oh! They will cut into bone, but the human skin and flesh will comply to the tool and will not be cut. A hard piece of bone will be cut. So if you do bone engraving, this is your tool. One tool that I really like for heavy deburring is a right angle air die grinder, 90-degree angle head. This is like a small angle grinder, electric grinder, but very light, very easy to operate, and you can get into very tight spots with it. And I have a selection of tools that I use most of the time with it. Most of the time I have a 3M Rolock disc adapter in it, and the discs that go in it have a very short, very steep 2-star thread on the end, and you just twist them on and you're good to go. I have sanding discs, these flapper wheels, these strange cleaning discs, and 3M bristle discs. Bristle discs are plastic brushes with abrasive in it. These are more for finishing. Most of the time I use the cheap 3M sanding pads for heavy deburring. When I have something directly off the bandsaw and it has a burr, I have this hanging next to my bench vise all the time, and I just hit it with the sanding disc and knock down the sharp edge. But the relatively rough sanding discs produce quite a bit of secondary burr, so you might have to hit it a second time over the surface. But that's a very fast way for, especially when you do fabrication work. Have an air grinder with a sanding disc next to your bandsaw. Very helpful. Sometimes for heavier stock removal, the flap disc is a good thing. For very fine deburring, I find these useful. Cleaning discs 3M. You can blend the surface, a radius and another surface into each other very nicely. Same goes for the 3M Scotch-Brite pads that you can get for this system, which I don't have here. I don't stock them generally, and this is really more for polishing and cleaning off remaining very fine burrs. If you want to do very heavy deburring, get a carbide burr for your die grinder, 6mm or 1/4 inch shank. This can remove quite a lot of material in a very short amount of time and wreak havoc if you get a catch with it. And then there are a few more good techniques to finish a part. Let's say we have this part and we nicely rounded over the edge. We took a file and we balled over the corner so it's no sharp corner in any direction. We can take a sanding sponge. These are out of the fingernail finishing something. For in the beauty store you can get them, or you can also use the sanding sponges from the woodworking guys. They work also quite well. But I found these from the beauty store super cheap on eBay. I think a box with 50 of these costs about $7. So they are disposable. And you just blend the radius that you created over with the sanding sponge. If you want to, you can really blend it into the surface if the surface finish on your part allows it. If you have a surface finish callout, you cannot do this. If you need a grinding finish with a defined surface roughness, do not do this. And as you can see, this blends the radius, the bald edge or corner, and surfaces nicely into each other. If you want to even more refine it, take some superfine Scotch-Brite. I cut the Scotch-Brite up in small pads because I find it more useful that way. And then you can really get into it and refine it even more. And that way you can create a product that looks like somebody cared about it. And if you deliver a part that already looks good, it instills the confidence that care was taken due to the whole process of making the part. A part that looks shabby is most of the times shabby machined too. Angles are not square, surfaces are not flat, yada yada. Even if it meets spec, it can look like crap and be on the edge of being a usable part. But if you take care and everything is just well done, it will instill the confidence of a good part. If you take a measurement of a crappy part and it's hard to get a consistent reading, would you really trust that part? If you have a part with nice surface finish, good flat surfaces, clean, crisp corners, chamfers, roundovers, and you take a measurement on the surfaces and everything comes out repeatable, that's the thing you want. And it will also instill confidence in you, and your customer will have confidence in you and stuff like that. Just the the small things that matter. That leads us to the last thing I wanted to talk about, deburring machines. There are a whole variety of deburring machines on the market. Most of them are relatively expensive for whatever reason. You can get them with end mills, with insertable end mills, face mills, big grinding wheels with flapper wheels. There are all kinds of varieties. What I find the most useful is the V-block type with an end mill that uses the front cutting edges of an end mill to create a 45-degree chamfer. You're basically face milling. That has advantages over other designs because it's not prone to pull the part into the tool as you're face milling, so you don't have climb or conventional milling, and it leaves a relatively good surface finish, and a 6mm carbide end mill like this machine uses is super cheap. This machine is shop built. I have a video where I show the construction and the use of this machine in detail. I will link it down in the description, of course. And something like this works really very fast. So, as you can see, this produces a very crisp and clean chamfer, very consistent and very fast, but being a face milling operation, it leaves, of course, a burr. So, after you put on the heavy chamfer, you just run a file lightly along the edges, maybe with a sanding sponge. And give it the finishing touch that it deserves, and then you have a chamfer that is crisp, clean, and has no secondary burr to it, and looks pretty darn good. Or to take a piece of Scotch-Brite. So this is a very good way for, especially if you have a lot of parts with long straight edges. The deburring machine is very nice. There are other machines that can do free-form deburring, like with a pin router for the woodworking guys. That works quite well. You can use a handheld woodworking router in aluminum if you have larger parts, with a bearing guided roundover or a chamfer bit. That's also an option. Yeah, and you can use a chamfer end mill in the milling machine. That's also an option, but on a manual mill that's relatively slow. If you have the option and you're running a CNC machine, it's of course the best thing to use a chamfer bit and chamfer a part if you need. They're just chamfered. If you want them just burr free, you might have to go through the trouble of, after taking a contouring pass, facing pass, repeat the contouring pass to clean off the burr and leave a clean part without a chamfer but a sharp edge. Maybe that's what you need or want, or specced out on the drawing of the part you're making. Okay, I hope I could give you a good overview of different tools and techniques for deburring, chamfering, rounding over, what's good practice, what's not, and so forth. So, hope you enjoyed. Thank you all for watching and see you next time.